Yes, good morning, children. Let us see today aromaticity and the corresponding Huckel's rule to decide the aromaticity or to identify whether a particular compound is aromatic or not. Okay. Now, what are the necessary conditions to be aromatic? The molecule should be planar. Planar means what? The carbon should be sp2 hybridized. You have studied sp2 hybridized carbon will be planar and sp3 will be tetrahedral, sp will be linear. All these things you already know it. Okay. So sp2 means planar. Planar means like this. It should contain 4n plus 2 pi electrons. The number of pi electrons should be equal to a value which is equal to 4n plus 2. Now, when you know how many pi electrons are there in that particular compound, you equate it to this 4n plus 2 and derive the value of n from that. If it comes to be, say, 0, 1, 2, 3, etc., then the substance is said to be aromatic. Okay? And these pi electrons, they should be above and below the plane of the ring, like how we saw the structure of benzene, right? As a duff net. One set of lobes above the plane, one set of lobes below the plane. Okay, so this is forming like a duff net. So if any one condition, if it is not satisfied, then the substance is not aromatic. Okay, so these two conditions are very, very essential that a particular substance is aromatic. If not, then it is non-aromatic. Now let us see a few examples. First, let us take benzene. And you know that the number of pi electrons, there are 3 pi bonds, so the number of pi electrons are 6. And you equate it to 4n plus 2 and derive the value of n, which is equal to 1, which is corresponding to the condition, right? So benzene is aromatic, and so also, since each and every carbon is a double bonded carbon, they are all sp2 hybridized, so benzene is aromatic. Now let us take a few more examples. Say like this. This is called as Cyclopropanil Cation. This is cyclic. The number of carbon atoms are 3. So it is cyclo. One double bond is there. So propenyl. At a positive charge is there. So cation. Right? Now let us see how it is aromatic. Now there is only one pi bond. Okay. So 4n plus 2 is equal to 2. And one more thing. These two carbon atoms are double bonded. So they are sp2 hybridized. And you already know that C positive is also sp2 hybridized. Is it not? So you have studied that. If you consider C, it is 1s2, 2s2, 2p2. Then what will be your C plus? C plus will be like this. Now C plus in the excited state, one electron will be up here. So there will be only 3 unpaired electrons which can participate in hybridization. So you say C plus is sp2 hybridized. Like this. Okay, these 3 will participate. So this is satisfying the condition, so it is aromatic. Now let us see another. This is Cyclopentadienyl Anion. There are 2 double bonds and it is cyclic, made up of 5 carbon atoms. So it is Cyclopentadienyl Anion. Okay. Now let us see here. There are 2 pi bonds and there is a lone pair of electron here. So when you count the number of pi electrons, if at all there is any lone pair, then that is also to be counted. So 2 pi bonds will make up 4 and 1 lone pair together it makes up 6. So 4n plus 2 is 6. So 4n is equal to 4 or n is equal to 1. So this is also aromatic. Now let us see another. Here you can consider the next example. Look how many carbon atoms are there. 1, 2, 3, 4, 5, 6, 7. There are 7 carbon atoms, cyclic. 3 pi bonds are there. This carbon is positively charged. So all the carbon atoms are sp2 hybridized. It is cycloheptadienyl cation. There are 3 double bonds, is it not? So it is trienyl cation. Now here 4n plus 2 is equal to 6. So 4n is equal to 4 or n is equal to 1. So this is also aromatic. Okay. So this is how you find out whether a particular substance is aromatic or not. Now let us see some more examples and let us find out whether they are aromatic or not. Now look here. There are 3 carbon atoms, 1 pi bond, and there is a lone pair of electron. So here in these examples, what we are going to see now, there are 4n pi electrons. That is, instead of taking 4n plus 2 is equal to the number of pi electrons, here we are going to take 4n number of pi electrons. The previous examples we saw 4n plus 2 pi electrons. Here we are going to take 4n pi electrons. That's what is there, right? So 4n is equal to 4, so n is equal to 1. So it is not in accordance with 4n plus 2, which is your Huckel's rule. Okay, this is not there. This is planar only. This is called as Cyclopropanil Anion because there is a negative charge. And since it is not abiding by 4n plus 2 rule, it is abiding by 4n pi electrons, it is called as anti-aromatic. It is not aromatic, it is anti-aromatic. Now take this. This is cyclobutadiene. Now here also you find all the carbon atoms sp2 hybridized. And again 4n is equal to 4, n is equal to 1. So cyclobutadiene is also anti-aromatic. It is not aromatic, it is anti-aromatic. Another example, see. This is cyclopentadienyl cation. We saw anion before. Today, now we are seeing cation. Now here there are 2 pi bonds. This is a positively charged. So 4n is equal to 4, n is equal to 1. Since this is also not abiding by 4n plus 2 rule, this is also anti-aromatic. Now in general, how you consider these two, aromatic and anti-aromatic. Aromatic compounds are unusually stable, they are highly stable. Whereas anti-aromatic substances, they are unusually unstable. See the big difference. Both are cyclic, both are conjugated. Whereas in aromatic you have 4n plus 2 pi electrons. Whereas in anti-aromatic you have only 4n pi electrons. Now these two examples, the best ones to indicate that. Unusually unstable. Look at the stability of that molecule. It is stable below minus 100 degrees Celsius. So you have to provide such a low temperature, only then this molecule will be stable. Okay. Now there is an interesting way to identify this which I found. Now see whether you are able to follow. Here I have taken the species. So I am just entering all these things to find out the substance whether it is aromatic or not. Okay. Now here the substance is cyclic. Is it conjugated? Yes. How many pi bonds are there? 3. Is there any lone pair? No. How many pi electrons? 6. Is it following Huckel's rule? Yes. Then it is aromatic. Okay. Huckel's rule means here you have to see whether 4n plus 2 rule is followed or not. Then again here in this, it is cyclic, it is conjugated. Conjugated means alternating double and single bond, right? Number of pi bond, it is only 1 in number, no lone pair. So 1 pi bond means 2 electrons. Whether it is following Huckel's rule? Yes. 4n plus 2 is equal to 2. Right? So it will be equal to, accordingly you can calculate. And aromatic is it? Yes. Same way, this, it is cyclic, it is conjugated. Number of pi bonds are 2 in number. There are no lone pairs. Pi electrons are 4 in number. Now look at the Huckel's rule here. 4n plus 2 is equal to 4. So 4n is equal to 2. So n is equal to half. Now half is not counted. According to 4n plus 2, it should be 0, 1, 2, 3 like that. Is it not? Whole numbers hona chahiye. So if it is a fraction, it is not allowed. That means this is not aromatic. Right? Same way, look at the next one. This is S, this is S. Pi bonds are 2 in number. Lone pair, there is one lone pair. Okay. So how many pi electrons? You count the lone pair of electron also. So 4 plus 2 is equal to 6. Is it following Huckel's rule? Yes. So it is aromatic. Right? So this is how you find out.